Welcome. Let's take a look at finding the critical points of the function f of x equals x squared over quantity x squared minus 16. As this is a rational function, we need to be cognizant of the domain restrictions that apply to this particular function. So in the case of a rational function, domain restrictions come from points at which the denominator is equal to 0. So, for example, in this case, we will look at for domain restrictions by looking at x squared minus 16 equals 0. We can go ahead and add 16 to both sides of this equation, and we get x squared equals 16. And then we can take the square root of both sides of the equation, and in doing that, we end up with x equals plus or minus the square root of 16, which is the same as saying plus or minus 4. Now, what this is telling us is that the denominator of our function f of x is equal to 0 when x is either positive 4 or negative 4. So we will want to remind ourselves that x cannot equal positive or negative 4. Now, you might be wondering why that's important. Well, down here, remember our definition for a critical point. So let A be an interior point of the domain of a function. So the domain of this function is all real numbers except positive and negative 4. If f prime of a or f is 0 or f prime of a is undefined, then a is a critical point. So the key here being the fact that it has to be an interior point. So in the case of this particular function, the function is defined for all real numbers except for positive and negative 4. So if I wrote this in interval notation, it would look something like negative infinity up to negative 4, union, negative 4 to 4, union, 4 on to infinity. And so negative 4 and 4 are not considered interior points. They are not interior to these intervals. Therefore, if we happen to run across a critical point that is either positive or negative 4, it would not be a critical point. So if we happen to come across an x value a such that either f prime of a is 0 or f prime of a is undefined, it would not be a critical point because negative 4 or 4 is not interior to any of these intervals. Okay, so that's enough about that. Let's go ahead and take a look at finding the derivative here so we can potentially find critical points. Now, since this is a rational function, it looks like a quotient, I'm going to go ahead and use the quotient rule. So f prime of x is going to be the derivative of the numerator, so 2x, times the denominator, so x squared minus 16, minus the derivative of the denominator, that's 2x, times the numerator, which is x squared, all over the quantity x squared minus 16 squared. So let's go ahead and expand out that numerator. So using the distributive property in the numerator, we're going to end up with 2x cubed minus 32x minus 2x cubed all over x squared minus 16 quantity squared. Now we can see that this positive 2x cubed in the numerator minus this 2x cubed, those two are going to combine to equal 0. And so our derivative here, f prime of x, is equal to negative 32x over the quantity x squared minus 16 squared. Okay, so now that we have our derivative, I'm going to write it over here on the left. So f prime of x equals negative 32x over the quantity x squared minus 16 squared. Now, we are looking for critical points. That is the task here. So we want to do two things. We want to consider where f prime of x equals 0 and where f prime of x is undefined. So those are the two things we have to consider. So first, f prime of x equals 0 means we're looking for where negative 32x over the quantity x squared minus 16 squared equals 0. Well, I can multiply both sides of that equation by the quantity x squared minus 16 squared. And on the right-hand side, that's going to be multiplied by 0. And so that will end up being 0. And on the left-hand side, that will simplify to be a 1. And so we'll have negative 32x equals 0. I can then divide both sides of this equation by negative 32, which gives me x equals 0. So, is x equals 0 an interior point? Sure, it's an interior point. X equals 0 is in that interval right there. So x equals 0 can be a critical point. So we've got one critical point so far. Now let's go ahead and consider the second source. That is where the derivative is undefined. Now looking at our derivative, we have negative 32x over the quantity x squared minus 16 squared. And we want this to be undefined. And so with rational functions, like this one here, like this derivative, they are undefined where the denominator equals 0. So this undefined tells me, in the case of a rational function, does this denominator equal 0? That's what we have to think about. Equals 0. There we go. Well, our denominator is x squared minus 16 quantity squared. We can take the square root of both sides of that equation, and we get x squared minus 16. On the right-hand side, if I take the square root, I basically have the square root of 0, so plus or minus the square root of 0. Well, that's really just 0. If that's equal to 0, we can add 16 to both sides of the equation, and this should start to look familiar. X squared equals 16. Apply the square root property again. Applying the square root property, we get just x on the left equals plus or minus the square root of 16 on the right, and x equals plus or minus 4. And notice that we solved a somewhat similar equation when we were dealing with the domain of the function. So these are, you could imagine them, you could call them potential critical points. And what we need to know is, are these interior points? Remember, that's part of the definition. Well, notice that -4 is not an interior point. It is not inside that interval. It's at a boundary. -4 is on the left boundary of this first interval, and on the right boundary, oh, I got that backwards. On the right boundary of the first interval and on the left boundary of the second interval. And +4 is on the right boundary of the second interval and on the left boundary of the third interval. The point being, these are not interior points. And since they are not interior points, they cannot be critical points. So what we end up with is that there is one critical point for this particular function, and that critical point is x = 0. I hope you find this helpful.